Hello, in this video we're going to look at recursive sequences, understanding the basics of them, and how to read the notation involved in recursive sequences. So a sequence is of course a pattern, like a string of numbers that has a pattern. At least that's a very simple definition of it. And then recursive, so that means a sequence that is defined recursively. That doesn't help much. Recursively means to be built on from a previous iteration, to be built on something previous. So a recursive sequence means in order to find the next term, the next number in the pattern, you have to know the previous term. An example of a recursive sequence is given right here. A sub n equals 2 times a sub n minus 1 plus a sub n minus 2. So that's saying to find the next term, you have to take 2 times the term n minus 1, which that's 1 before the nth term, so 2 times the previous term, plus the term 2 terms before. Okay, the n minus 2 means you take the nth term, which the next term is kind of the nth term, the term you're on, the term you're trying to find, and you go minus 2. You take 2 steps backwards. 2 terms back. So in practice, we look at what's a sub 1. Well, a sub 1 is given to us. It is 2. And a sub 2 is also given to us. That is 3. So see, with a recursive sequence, we have to be given our starting point. Because if I just said find a sub 1 and I don't tell you, the formula says I have to do 2 times a sub 0, 2 times the one before, plus 2 times a sub -1, which is 2 terms before the first term. See, and I don't know what those numbers are. So you do also have to be given this starting information in order to start a sequence. And notice how I'm given 2 starting bits. That's because I have a sub n minus 1 and a sub n minus 2. So my formula or my rule, it calls 2 different previous terms. So I need to start with 2 terms. If my formula did not have this right here and it only called the previous term, well then I would only need 1 starting term. Okay, because I'd only have to reference 1 term back. But in this case, we reference 2 back, so here we are. So now we can try and find a sub 3. So before putting in numbers, what does the formula say? It says 2 times a sub n, which in this case, what is n? 3, minus 1, plus a sub n minus 2. We simplify that a little bit. It's 2 times a sub 2 plus a sub 1. And remember, these a sub 2, a sub 1, they are standing for that position in the sequence. So the 2 means the second position in the sequence. And our second position has a number 3 right there. So we can do this again, and we can go 2 times a sub 2 is 3 plus a sub 1, which is 2. So we have 6 plus 2, which is 8. So we just found that a sub 3 is 8. Now let's take a little quicker as we find a sub 4. A sub 4 is equal to 2 times the previous term, which is a sub 3, plus the term 2 before, which is a sub 2. So that is 2 times what is the third term? 8. Plus what is the second term? 3. So we get 16 plus 3 is equal to 19. So that's the fourth term. The fifth term, that's 2 times the previous one, which is a sub 4, plus the term 2 before, which is a sub 3. So we go 2 times 19 plus the third term, which is 8. So we get 38 plus 8, which is 46 for the fifth term. So we answered the question, what is the first 5 terms, and we found them. But let me go just one further, a sub 6, real quick. So 2 times the previous term plus the term 2 behind it, which is the fourth term, which is 19. So 2 times 46 is 92 plus 19, which gives me 111 for the sixth term. So you can get in the flow of that recursive sequence. And we found our first 6 terms actually, 2, 3, 8, 19, 46, and 111. So you see, with a recursive sequence, you have to know the term previous in order to find the next one. So the only way to find the, say, 20th term is to find all 19 terms before it, and then you can find the 20th term. So recursive sequences allow you to define a more tricky type of pattern, but they're also limiting because you can't just jump to the 40th term right away and find just that. You have to find all the terms before it. Okay, let's practice writing a recursive sequence. And it says write one single recursive sequence that describes each of the 3 sequences. So you see that there are 3 different sequences, but yet I'm actually able to write one single recursive sequence that would define all of those. Let's start off by going the easier route and writing each their own sequence. What do we know is the pattern in this first one? Well, it's plus 3, plus 3, plus 3. So you're taking each term and adding 3. How do I get to the next one? I take the previous term plus 3. What's that again? How do I get to the next term? I take the previous term, a sub n minus 1, plus 3. Easy as that. Of course, I always have to give the starting point, so how do I start it? A sub 1 is equal to 5. I only need 1 because in my formula, I only reference one previous number. The second one, how do I get to the next term? Well, let's see the pattern. Plus 2, plus 2, plus 2. So to get to the next term, I take the previous term, a sub n minus 1, plus 2. And I start at a sub 1 equals 4. Easy. The third one, how do I get to the next term? It looks like I'm adding 10, plus 10, plus 10, plus 10. So to get to the next term, I take the previous term plus 10. And where do I start? At 10. Okay, so there, I wrote a recursive sequence for each of them, but they're all a little bit different. Can I find a way to write a single formula that describes all 3 of those? I can, and it does take a little bit of looking to figure it out. These are all called arithmetic sequences because I'm adding to get to the next term. I'm adding the same value each time to get to the next number. That's what we call an arithmetic sequence. And there is one type of recursive sequence that can be written to describe an arithmetic sequence. Or there is one type of recursive rule that can be written to describe an arithmetic sequence. And I'm going to lay it out because it takes some puzzling, some looking at to figure this out. But you can actually go 2 times the previous term minus the term 2 before it. And that's going to work for all of these. Okay, if I look at the first sequence, how do I get a sub 3? I would go 2 times 8, the previous term, minus the term 2 before. That's 16 minus 5, which is 11, which is indeed our third term. That's neat. Let's go to the second one. What if I try and find the third term of that? I'm going to go 2 times the previous term, which is 6, minus the 1 2 before, which is 4. That gives me 12 minus 4, which is 8. Hey, and that's the third term of this one. Okay, will it work for the third one? Come on, come on, come on. We're going 2 times the previous term of 20 minus the first term, which is, come on, work for me, 30. Hey, that is in fact the third term, what we were trying to find. And that would work if I try and go back and find a sub 4 of the first sequence. That would be 2 times 11 minus 8. So that's 22 minus 8, which is 14. Checks out. That's our fourth term. Okay, and that's going to work for all. So I think that's pretty cool how I can write this one recursive sequence that describes all 3 of those. Now, the only thing that's going to change is I'm going to have to give different starting points for each one. So this one is a sub 1 equals 5, and then a sub 2 equals 8. I would have to provide that. And then for the second one, I would have to write, oh, well, for this one, a sub 1 equals 4, a sub 2 equals 6. And for the third one, a sub 1 is 10, a sub 2 is 20. And I'd have to provide that different information. But the general rule, the general formula is the same. That's the general rule for any arithmetic sequence if you want to write it with a recursive rule. Okay, so there's the basics of understanding recursive sequences, trying to write a recursive rule, and also using a recursive rule to write the sequence itself.